All right, last but not least, question 3. The only difference between question 2 and question 3 is that question 2 was a two-tailed test. And the way we knew that is our null hypothesis was that we were told that the mean height was 44, and we think that it's not 44. In question 3, it's known that the average weight for second graders is at most 48 pounds, and we're speculating that there's been an increase. Anytime you're speculating that there's been an increase, or you're speculating that there's been a decrease, that's a one-tailed test. And when you use Excel for a one-tailed test, you're still using a 5% confidence level or 5% significance level. But the thing is, in Excel, we have to trick Excel and tell it that we're using a 90%, also known as like a 10 on either end. Just because Excel isn't specifically a statistical software, we have to trick it into doing a 5% level and a one-tailed test. Long story short, you don't need to know how to do that, but I want you to understand why this one says 90 and the other one said 95. Excel can do a two-tailed test, no problem, but when doing a one-tailed test, and again, we know it's one-tailed because we're looking for an increase specifically, we want our confidence level to say 90. It's just tricking Excel into doing what we want. So anyway, we're doing a hypothesis test to figure out if the weight is 48 or higher than 48. So our null hypothesis is that weight is at most 48. In other words, the mean is less than or equal to 48. Our alternative hypothesis is then whether there's been an increase or not. So our alternative hypothesis is that weight is higher than 48. Okay? Our significance level is 5%. Our type of error is going to be type 1 because it's always going to be type 1. And now we need to figure out a conclusion. Well, just like in problem 2, to get a conclusion, what we need is a confidence interval. And that's two numbers that we want to test this 48 on. So I am going to figure out those two numbers because it wasn't given to you this time. The two numbers to get your confidence interval are going to be your mean plus the confidence level and your mean minus the confidence level. All right, so our mean plus the confidence level, what I can do to get that is I can click on this cell here, hit equals, which you're going to see show up here. I'm going to hit equals, and then I'm going to take the mean, hit the plus, and then touch the confidence level, hit enter. There's our upper level, and then the mean minus the confidence level. I'm going to hit equals, mean minus confidence level, enter. And I'm going to look at these two numbers, and I'm going to determine whether 48 is in those numbers or not. Okay? Is 48 in between 48.8 and 48.2? It is not. So these numbers are both higher than 48, which means that we can reject the null hypothesis and support the alternative hypothesis. Therefore, weight has increased. Now, let's pretend for a second, okay, I'm just going to mess everything up for a minute. Let's pretend for a second that we think that the weight is at most 50 pounds. So if I change this to 50, weight is at most 50. And weight is higher than 50. Now I want to look at this and say, okay, is 50 in here? No. What kind of numbers are these? Are they more than 50 or less than 50? Well, 48 is less than 50. So does that mean there's been an increase in weight? Well, no, because these are less than 50. So whenever that happens, whenever your null hypothesis is supported, you can say that we cannot reject H sub O and must therefore allow for H sub O to be true. Okay, there's a lot of different ways to state that conclusion, but basically if you don't have enough information to support your null hypothesis, I'm sorry, if you don't have enough information to support your alternative hypothesis, that just means you support the null hypothesis. Okay? So, long story short, you want to look at these numbers right here, see if the number you're testing is inside or outside, see which of these you're supporting, and then that becomes your conclusion.